Okay, problem 32. This is an involved one, and if you really weren't sure how to start it, I encourage you to pause the video right here and pay attention to the fact that this is really a trig problem. So now that you have that understanding, see if you can go back and solve it. I'll let you know that for me, I solved this problem simply by looking at the diagram. Once I saw that, that's how I knew it was trig, because they're giving me angles of reference and I have a right triangle. That's just my clue. So when I read this, I'm going to emphasize those pieces that are in here that they've already given you in the diagram. Um, the sentence is kind of superfluous. So it says, as shown in the diagram below, there's a ship, as represented by A, heading directly towards the lighthouse, as represented by C. And then they tell you this beacon, point B, is 125 feet above sea level. It just means that its length is 125. It says at first sighting point A, the angle of elevation, the angle that the bottom makes all the way to the top, right? Makes from the bottom to the top. This angle is 7 degrees. And it says a short time later, as this ship keeps on going and hits point D, that angle changes. Now, when we look at the angle from the ship at D to the top, now it's 16 degrees. So they're asking you, here's the question, they want you to round. To the nearest foot, determine and state how far the ship has traveled from from point A to point D. So what they're really asking you is this distance here, right, from point A to point D. How far did it travel? They want to know its value. So I'm going to give that a variable. I'm going to call it Z. I'm using Z because I know I'm going to solve for two other things. It's just forward thinking. So to figure out Z, I need to figure out a couple things. I need to be able to see that I have two right triangles. I've got this big initial one. So from A to C to B, all right? So I could figure out that length, and that length I'm going to call X. The other thing I could do, and I guess I'll show you that. There's this big right triangle, and I'll label it. It's A, right? A. There's a D somewhere over here, and then it goes to C, and then it ends at B, and it's right there. I know this is 125. I know this angle is 7, and I know this is a right. The other triangle we have, the other right triangle, is this one at D to B to C. Okay, so I'm going to do that one over here. It's not to scale. I'm just using it so I have something to go off of. So it goes from D, right, now we're going from D. We're not using A, to C to B. And this is still 125, but now this angle is 16. Okay, so if I find that length, right, that will be Y. That will be this length here. And I could do the blue length X, take away the red length Y to figure out Z. And that's how I'm going to get there. I need to find the total, I need to find one part, and then I can subtract those parts. So let's start with the blue. When you have a right triangle, a side, and an angle, you know this is trig. We're going to use SOHCAHTOA. Okay? And first thing we should do is label our triangle. So this is my reference angle. That's what orients us. So I like to label the opposite first, the thing across, the side across from it. Then the hypotenuse. I know my 90-degree angle is here. So if I go across, that will be the hypotenuse. What I'm interested in is the adjacent. I'm interested in this side. I want to know what's that length. So when I do trig, I'm going to use the adjacent and the opposite. And that's not sine, because that's opposite hypotenuse. That's not cosine, because that's adjacent hypotenuse. We don't care about the hypotenuse. This is going to be tangent, okay? So I'm going to write my function. It's the tangent of my angle has to equal the opposite over the adjacent. So let's substitute now. Well, my angle is 7 degrees, so it's the tangent of 7. my opposite is 125, and my adjacent is the thing I'm looking for. So if you do some cross multiplication, put this over 1, you're going to have 1 times 125 is 125. And then this is going to be x times the tangent of 7. Okay? And I'm solving for x, so I want to divide by the thing that's bothering x, which is the tangent of 7. If I divide by that, they'll cancel. So I can see x really equals 125 divided by the tangent of 7. So if I type that in the calculator, oh, here's the thing. Whenever you're doing trig, you need to make sure your calculator is in degrees. So I reset the calculator on the day of the Regents. Your calculator is going to be fresh. It's going to be reset. So you need to do this. You need to hit mode and then verify that your calculator, if we scroll down, it's not in radian. It can't be in radian. It needs to be degrees. So you actually need to do this just like I'm doing now. You need to go right, hit degree, hit enter, and then second quit. And I encourage you to check it. Hit mode again and just verify, yes, it's on degree. So now I'm ready to do some trig. I'm ready to do what I have written on my scratch paper. 125 divided by the tangent of 7. And I'm going to get a value. And remember, they said to the nearest foot. So x is approximately, I'm rounding to the ones digit. There's a 0, so I just get rid of all the decimals. It's not 5 or higher. So it's 1018. So x is approximately 1018. So we're just going to repeat this now for the other triangle. So if you didn't get to this point, you needed to see one of the triangles solved, great. I encourage you to stop the video, try the other one, and see if you can come up with the final solution. So here's a great moment to stop. Continuing on. So once again, I'm going to repeat the steps. I'm just going to label all the parts of my right triangle. This is my reference angle. Therefore, this is the opposite side. Here's my 90-degree angle. Therefore, this is the hypotenuse. The thing I'm looking for is y. It's that side DC. So this is the side I'm looking for, and that happens to be the adjacent. So I don't care about the hypotenuse. That's why I can cross out sine and cosine. I'm really interested in tangent because I have my opposite, and I'm looking for the adjacent. So this is, once again, the tangent of whatever my reference angle is. That has to be equal to whatever my opposite side is divided by my adjacent. You can just write the next stuff that I'm writing in. It's the tangent of my angle, 16, has to equal my opposite side, 125, divided by y. And, you can see here that what happens is, let's just turn this into a proportion. Put it over 1, cross multiply. But what's going to happen is the tangent of 16 and the y, they're going to switch places. In the end, I'm going to have y equals 125 over the tangent of 16. All right, but I'll show you. I'll go through the long way. When we cross multiply, we'll have 1 times 125, which is 125. Then we're going to have y times the tangent of 16. So tangent of 16 is bothering y through multiplication, so I divide to get rid of the tangent of 16. Whatever I do to one side, I do to the other. And there you go. This is what I was saying. The y and the tangent 16 swap places. They're interchangeable. That's a property of cross multiplication. So to figure out y, I just do on my calculator, which is in degrees, 125 divided by the tangent of 16. And once again, we're rounding to the nearest foot. So I have 435, but my decimal, my tenths place is a 9. So I have to round that 5 to a 6 and then drop all the decimals. So y is about 436. Y is approximately 436. So up here, we know that x is about 1018 and y is about 436. So to figure out z, it's just 1018 minus 436. 1018 minus 436. So we're going to get 582. Z equals about 582. So you could show that work. You can say Z equals 1018 minus 436, which equals 532? 582, that's it. 582. Boom. And you are good. You just want to be clear. You can say the length of AD equals 582 feet. Yeah. Awesome.